Hello and welcome to my video for my final year project using the Arduino GSM shield and the GPS. I've already covered the basis of the code in the introduction, so I'll just move straight on to the demonstration. Hopefully that's a good angle. So with the serial monitor open, take it off auto scroll, you can see that the GSM is initialized, waiting for messages, and it acquires a GPS fix. It won't start looking for new messages until that fix is found. And I've just got it on a printout constantly for my peace of mind, basically, that I'm in fact receiving the GPS position. It's a standard code pretty much. I've defined my variables and go straight into the setup, which initializes the ports and the GSM shield into my loop, which checks for messages and the authorization number, and then uses the sms.peak function to go into the 3 different modes. So we'll start by sending it a text and see what happens. So the first mode I'm going to do is the instant update. This will just gather the position, compile a message, and send a URL with Google Maps to my position. So I'm sending to the Arduino, and you can see at the bottom we've got a received from my number, and it's the admin number, and then it's acted on that admin number, detected, instant update mode selected, and you can see here that I've received a message with the coordinates, how many satellites are connected to it, and that takes me to a nice map with my current position. Okay, and then this starts looping again, waiting for the next message. It deletes each message after it has been fulfilled. So now I'm going to send it an 8, which is the movement detection mode. This mode works by comparing the first set coordinates with the next set of coordinates after a delay, and it will check through 5 times. And as you can see here, it says vehicle has not moved each time it's checked, and then it will send me a message to say that my vehicle hasn't moved and the function has ended. So you can see here on my phone, movement detection mode initiated. If your car moves, we'll let you know. And it just says Arduino stop checking for movement. To restart, please send an 8. I will do a separate video with the actual function working with the real sort of coordinates on there. But that's the end of that function, and again it's just going through on its constant loop now. So it's scrolling away, and what I'm going to do now is send it a message requesting the periodic updates. So I'm going to send it a 2, and here you can see my number, admin number, and the periodic update selected. Now this will start my UBDOS request, HTTP request, and it's starting the Arduino client, so it's connecting the GSM. After a short delay, it will connect GPRS, and in addition to that, it's also sent me my first message as well. I've kept the SMS messages in now as a more of a debugging confirmation. Eventually I'll remove that completely, so it just updates And here you have the path. So it's a post rather than a GET request. Host is UBdots, content type is JSON, content length, and then this is the actual body itself with the latitude and longitude. It's important to flush and disconnect each time as well, otherwise memory starts becoming an issue, outgoing bytes, etc. So it's just good to disconnect each time and then reconnect. I felt that's the best way to keep it flowing a lot better. Here we go. Just going through the process again, and in a real life situation there'd be a longer delay suitable for the journey type that you're going to be having. 5-minute delay, half an hour delay between these updates to get a better trace on the UBdots map. But for presentation purposes, I've kept the delay quite short due to time constraints. So each time it goes through, it's sending me another update as well. So it should do it one more time. There we go. So here you go. The final text is the end of periodic updates. To reselect, please send a 1. To restart the periodic updates, okay? So now that will just loop through, waiting for the next set of messages. And if I change the view to this screen instead, this is UBdots, and if I refresh the page, I should have my 5 nice clean values with the latitude and longitude, and also the time of when they were sent with the date as well. And what that means is I've created a dashboard which plots the location on a map for you and will trace it as well. In a real life situation, this would be points rather than the same place, but obviously as I'm sat at the desk, the GPS location isn't going to change. Another thing to show you is the event that I've created, and what this is a geo fence. So if any point the location that's updated to UBDots is outside of this fence, I'll receive a SMS. So this basically works. I'll show you quickly. Location. So all I have to do, for example, is draw the shape around leads, and UBDots does the hard bit for me, I'll admit. And it will send a warning text that I've wrote, which is this. So as you can see, it says, "Hi Zach, your car has left the geofence. If this was you, please ignore. Otherwise, please text your Arduino for an instant update." So at that point, you could then send a 5 for that instant update from the URL from Google Maps, and that'll tell you where it is. So thank you for listening, and we'll move on with the presentation.